Okay, in the second part, I'm going to cover some transformations for those rational graphs that we have, or reciprocal graphs, if you want to use that word. Okay, I'm going to divide. So here's my parent again. So I'll be referencing this. I'm going to divide this and kind of do a half thing here and focus on, let me turn this a little bit. Focus on this graph. Hopefully it doesn't mess up your, actually, no, I can't do that. We'll do this, sorry. All right, so let's say we have, for instance, for example, y equals 1 over x plus 3 and then minus 2. Okay, so the first thing I'm going to do actually is note the differences in this. So we have a plus 3 and we have a minus 2 now. So if you remember your rules of transformations, this is stuff you've learned before, okay? Anytime you do something to the x, it's going to be a horizontal shift, okay? And anything to the y is going to be a vertical shift. So what we're going to do is we're going to look at this one first. For this 3, okay, this means that the graph is going to move 3 units to the left. Hopefully your teachers have told you that this is kind of, x always works the opposite. So instead of it being like right 3, it's actually going to be left, okay? And the y value is this outside one, your k value, so to speak, is going to be 2 units down. Okay, so what's going to move? Well, what's going to move in this case, the easiest thing to move will be your asymptote. So instead of it being here in the middle, this line, x equals 0, is going to move 3 units to the left, and this line is going to move 2 units down. So let's see what that looks like. I'm going to just do a quick sketch of this. So let's do our xy axis. Sorry, my notebook's moving a little bit. And I'm going to mark from 0, 3 units to the left. So 1, 2, 3, and 2 units down. 1, 2. And again, this is just a sketch. So it's not going to be perfect, but it's going to be pretty close to what you might get on a calculator, okay? And what I like to do is I like to mark these. So 3 units left, my asymptote used to be in the center, now it's over here. So it's going to be along -3, okay? Same thing with the y. So my horizontal asymptote, so this one, the purple one, was in the middle. Now it's going to move down by 2. So now it's going to go down 2 units. So it's going to go across right here, okay? And this kind of serves like your guideline to how to draw these, to how to draw your curves. So as long as this number in the top, so this is like our A, okay? As long as it's positive, then these two curves are still going to be like in this diagonal. So in other words, like this curve would be kind of like along these two lines, and this curve is going to be along these two lines, okay? And that's pretty much it. That's the general shape of what this graph will look like. If you start adding numbers up here, like put in a 2 or a 3, then obviously you're going to have some dilations. You might have vertical shrinks or compressions, but we're not going to deal with that. We're just dealing with left and right and negative or positive. So this is a positive 1. Therefore, that's where the graph is still going to be, you know, this quadrant, you can say, and this one. Okay, so let's do another one that's negative, just so you can see what happens if it's negative. So let's do another example. Remember that we're always comparing these to the original, okay? And I don't know if you know this, but the transformations that I'm referring to are in this format. Let me write it real quick. F of x, we'll do plus or minus h plus or minus k. So this is what I'm referring to, okay? Oh, and there's an a here too in the front. So the h is like where the 3 is, the k is where the 2 is, and the a would be that 1 right here, if it's positive or negative. Hopefully you know a little bit about transformations. If not, just let me know and I can try to help you out, okay? So let's look at a different example. We're going to have y equals -1 over x plus 3 and minus 1, just to make it negative, and so you can see what happens if that happens. This would be something like this. So you'd have your graph, okay? We would have, again, 3 to the left, so 3 units left. And I'm just using very basic terminology right now. The more accurate would be, you know, horizontal shift by 3 to the left or something like that. And then the 1 would be 1 unit down. So let's go ahead and do that. 3 units left would be at 1, 2, 3, -3. So it's kind of like the first one. The unit down would be 1 unit down, so -1. Okay. And now I can go ahead and draw my graph. So take note that this negative is going to reflect over the x-axis. So that means that the graph might have been here, so like in this area and this area, but now it's going to flip. So instead of being like this, it's going to be on the other side, like so. Okay, and that's your general form of what they're going to look like. Now, I did not mention the asymptotes too much, so let me go ahead and do that for this example. You can do that one if you want right now too. So since we drew these dotted lines, our vertical asymptote, and I'm going to put VA for vertical asymptote, okay, it's just going to be, well, this line right here. It's always denoted by x because x is always going to be equal to, in this case, -3. Our horizontal asymptote is the other one. So it's the one that I drew across like this and it's going through -1. So this one's going to be y equals -1. When we talk about our domain and range, I'm going to kind of color code this as well. Our domain would be everything except for that. So we could say, I'm going to do this two ways just so you can see it. It can be -infinity, so -infinity all the way to -3. Unite it with, well, -3 through infinity. Okay, so that's one way you could write it. You could write like each piece. So this piece is the first one, this piece is the second one, okay? Or if your teacher allows it, you could also say that the domain is going to be everything except for -3, because -3 is the only place where it's undefined, where we can't, we have that dotted line, the asymptote. So you could just say x is not equal to -3. And this automatically implies that, well, as long as it's not -3, it's everything else, okay? So, but again, it depends on your teacher or professor, so make sure you check with them before you do that. Let's look at the range for this one. So the range in this case is going to be everything from the bottom, so -infinity, all the way to this line right here, which happens to be -1. Okay, and again, we put a parentheses because it doesn't actually touch -1. Unite it with, well, everything on top, so -1 through infinity. So -1 through infinity. And just like I told you with the domain, we could write this as, we could say y not equal to -1. And that would suffice as well, so R for range. But again, check with your teacher or professor because they might want you to write it more formally like this, okay? And that's it for this problem. If you want to try maybe the domain and range for this one as practice, that would be great. Okay, hopefully this helped. Let me know if you have any questions.